Congratulations! You are now the proud father of several hundred babies. They are tiny, helpless, completely dependent on you. And unfortunately, they smell like breakfast. You are a small male fish guarding a nest beneath a rock. A female arrived, deposited her eggs, inspected your home for approximately 3 seconds, and disappeared. Now every egg is your responsibility. You fan them with your fins to keep oxygen flowing. You remove dirt, chase away hungry neighbors, barely sleep, and barely eat. You are doing everything a devoted father should do. Then you lean down and swallow one of your children. No warning, no seasoning, no awkward explanation to the remaining 400. This behavior is called filial cannibalism, a parent consuming some or all of its own offspring. It has been observed in fish, amphibians, reptiles, insects, spiders, birds, and mammals. At first, the explanation seems obvious. The parent must be starving. Sometimes that is exactly what is happening. But then scientists improve the animal's diet, remove obvious threats, and still watch the parent eat its babies, which means hunger is only the beginning. Under certain conditions, eating a few offspring can help save the rest. A dead baby can threaten an entire family. An overcrowded clutch may become impossible to keep alive. A small brood may no longer be worth guarding. Stress can also trigger an ancient emergency response that works far better in the wild than inside a glass cage in someone's bedroom. To understand any of this, return to the fish beneath the rock. You have not eaten properly for days. Leaving the nest to hunt would be dangerous. The moment you swim away, another fish could rush in and consume every egg. The neighborhood is full of animals waiting for you to make one irresponsible grocery trip. Fortunately, food is already inside the nest. Hundreds of soft, nutrient-rich eggs are attached to the rock directly in front of you. This creates a strange calculation. Refuse to eat any of them, and you may become too weak to defend the nest. A predator could then eat everything, consume the entire clutch, and you lose every offspring yourself. But swallowing a small number may provide enough energy to remain beside the nest, continue fanning the eggs, and keep attacking intruders. A few eggs disappear. The father survives. Most of the clutch remains protected. He is both the security guard and the thief, stealing from the shop he was hired to protect. This is partial filial cannibalism. Instead of destroying the entire brood, the parent consumes only a portion. From the perspective of the eaten egg, this arrangement is terrible. From the perspective of the parent's total number of surviving offspring, it may be profitable. Evolution does not ask whether every baby received equal treatment. It only measures how many copies of the parent's genes eventually survive and reproduce. That is the uncomfortable rule beneath the entire subject. Parents do not have unlimited energy. Egg production costs energy. Pregnancy costs energy. Birth, milk, warmth, protection, and constant vigilance all come from the same biological budget. Nature does not provide paid parental leave. Imagine a mother gives birth to 8 babies during a sudden food shortage. She has enough energy to raise 4 properly. Keeping all 8 alive for a while might seem like the best choice, but every baby receives less food. Growth slows, immune systems weaken, the mother loses body mass, and eventually the whole litter may die while she becomes too exhausted to reproduce again. Reducing the litter early can produce a different result. The smallest or weakest babies disappear. Some of the nutrients invested in them are recovered. The remaining offspring receive more milk, while the mother preserves enough energy to survive and care for them. This does not mean animals consciously calculate calories or hold a family vote. They respond to signals. One baby may be unusually cold, weak, injured, motionless, malformed, or unable to compete for food. A mother may detect a strange smell. A fish may notice that an egg has changed color. An amphibian may find fungal growth spreading across the clutch. The parent is not thinking. This child has disappointing long-term prospects. Its nervous system is reacting to physical information. Weak movement, abnormal temperature, rotting tissue, crowding, hunger, or danger. The result looks cruel, but the mechanism is often closer to emergency resource management. The easiest offspring to consume is one that is already dead. A dead baby can no longer reproduce or carry the parent's genes into the future. It can, however, attract predators, feed flies, spread parasites, rot beside living young, or provide a surface for fungus to invade the rest of the clutch. Leaving the body untouched can turn one loss into 10, so the parent eats it. The corpse disappears. Some nutrients are recovered. The nest becomes cleaner, and the smell that might attract scavengers grows weaker. A moment earlier, the baby was an investment. Now, it is dangerous organic material lying beside the nursery. This becomes especially important in species that produce dense clusters of eggs. Consider a giant salamander father guarding a mass of eggs inside a dark underwater den. He does not simply sit nearby looking proud. He fans the clutch with his tail, moving fresh water across the eggs. He turns and agitates them so oxygen can reach different parts of the mass. He also removes eggs that are dead, unfertilized, or beginning to decay. Sometimes he removes them by swallowing them. One egg turns cloudy. Fungal threads appear across its surface. If the father leaves it in place, the fungus may spread to the healthy eggs pressed against it. So the salamander eats the infected egg. It looks like cannibalism because it is cannibalism. Functionally, however, it is also nest cleaning. The salamander has no tweezers, trash bag, disinfectant, or tiny underwater medical team. It has a mouth. Destroying one offspring may protect dozens of others. This is the first major reversal. A parent eating its young is not always the opposite of parental care. Sometimes it is part of parental care, not gentle care, not care that humans would place inside a greeting card, but care measured by how many healthy offspring remain afterward. Overcrowding creates a similar problem. Hundreds of eggs packed together compete for oxygen. Water must move between them, waste must escape, and disease can spread wherever damaged eggs press against healthy ones. Now imagine your fish nest contains more eggs than you can properly fan. The embryos near the center receive less oxygen. Some begin to die. Dead eggs encourage infection, turning the clutch into a crowded underwater apartment building with no windows and several hundred tenants who cannot move. Removing part of the clutch reduces density. Water flows more easily. The remaining embryos receive more oxygen, and the father gains energy from the eggs he consumes. One action solves two problems. Again, the individual victims lose everything, but the survivors receive a better chance. Producing too many offspring is therefore not always a mistake. Wild environments are unpredictable. A parent cannot know exactly how much food will exist next week, how many predators will arrive, which eggs will be fertilized, or whether the weather will suddenly change. Producing extra offspring can be useful while conditions are good. If resources remain abundant, many survive. If the environment collapses, the parent can reduce the brood. Launch many tiny boats before the storm, then preserve the ones most likely to reach shore. But what happens when the entire reproductive attempt is no longer worth saving? Return once more to the fish father. Perhaps only a few eggs remain. Predators may already have eaten most of them. Maybe the clutch was poorly fertilized, or the female deposited too few eggs in the first place. The workload has not changed. You still need to fan the eggs, defend the nest, and sacrifice opportunities to feed. Caring for 20 eggs may cost almost as much as caring for 200. The effort remains high while the possible reproductive reward has collapsed. At that point, eating the entire clutch may be more profitable than continuing to guard it. This is total filial cannibalism. The parent does not merely reduce the brood, it ends the attempt. The eggs become energy, the nest is cleared. The male returns to feeding, restores his physical condition, and prepares to attract another female. Some male fish face an additional complication. Their bodies shift into parenting mode while eggs are present. Hormones supporting nest care can suppress courtship behavior. As long as a small, unsuccessful clutch remains, the male may continue guarding it instead of pursuing a better reproductive opportunity. He becomes trapped by a nursery that is no longer worth operating. Eating the eggs ends care, changes the hormonal state, and allows courtship to resume. The fish has not forgotten that he is a father. Remaining a father to that particular clutch may simply prevent him from producing a larger and more successful brood. This is the second major reversal. Sometimes the parent consumes babies not to preserve the current family, but to end a failed attempt and begin again. That sounds ruthless, but natural selection measures reproduction across an entire lifetime. Protecting 10 eggs may prevent a male from producing 300 more later. Saving the 10 looks carry in the moment, but it could leave fewer of his offspring alive overall. Evolution favors the largest lifetime result, not the nicest individual scene. Of course, not every case represents a perfectly tuned strategy. Sometimes the system misfires. This becomes especially obvious in mammals kept in captivity. A hamster gives birth inside a small enclosure. Then enormous human hands repeatedly enter the nest. The bedding is replaced. The babies acquire unfamiliar smells. Bright lights stay on. Noise fills the room. Food may be limited, and there is nowhere to hide. The mother receives the same message from every direction. The nest has been discovered. In the wild, she might carry the babies to a safer location. But relocation requires time, energy, and somewhere safe to go. Inside a cage, there may be no better destination. The mother cannot load the litter into a minivan and relocate to another forest. Her available responses are limited. Defend the nest, abandon it, move the babies repeatedly, or consume them. Eating the young can recover energy while removing helpless animals that may attract predators. In the environment where this response evolved, it may occasionally have prevented the mother from dying beside a doomed litter. Inside a bedroom, the behavior looks senseless because the supposed predator is a child checking whether the babies are cute. This is why disturbing newborn rodents can sometimes increase the risk of abandonment or cannibalism. Stress, however, is not a simple on and off switch. Species differ, and so do individuals. An experienced mother may respond differently from a first-time mother. Food, health, litter size, enclosure design, noise, and available hiding places all affect the outcome. The parent's brain combines many signals. Sometimes the final response is useful. Sometimes it is catastrophically wrong. A behavior does not need to work perfectly in every situation. It only needs to have improved reproductive success often enough across many generations. There is another complication. The babies may not actually belong to the parent guarding them. In many fish species, a male protects a nest containing eggs laid by several females. Rival males may sneak into the territory and fertilize part of the clutch. The guardian cannot conduct a DNA test. Instead, he relies on indirect clues. Was he present during spawning? Did rival males enter the territory? How much time and energy has he already invested? If the probability of parentage appears low, the value of continuing care may fall. Guarding another male's offspring means spending energy and risking injury to protect genes that are not yours. Unpaid childcare is already difficult. Unpaid childcare while being attacked by predators is worse. The clues are imperfect, however. A male cannot identify every egg precisely and may consume his own offspring along with those fertilized by rivals. Evolution produces workable shortcuts, not courtroom evidence. By this point, the same physical act can represent several different biological responses. A parent may remove dead or infected offspring to clean the nest, reduce a brood that has become too expensive, consume part of a clutch to gain energy or improve conditions for the survivors, end an unsuccessful reproductive attempt, or react to stress and uncertain parentage. Sometimes, several of these pressures occur at once. Sometimes the parent simply makes a mistake. One action can solve many different problems and occasionally create new ones. It is also important not to confuse filial cannibalism with every terrible event involving animal babies. When a new male lion takes over a pride and kills cubs, he is usually not killing his own offspring. That behavior is infanticide. Removing the cubs can cause the females to return to reproductive conditions sooner, giving the new male a chance to father his own young. The logic still involves reproduction, but it is a different calculation. Nature has multiple departments responsible for family disasters. Filial cannibalism is especially common where offspring are small, numerous, and relatively inexpensive to replace. A fish may produce hundreds or thousands of eggs. An insect may lay a large cluster. An amphibian may guard a dense mass of embryos. Losing one egg carries a much smaller biological cost than losing the only calf produced after a long pregnancy. An elephant mother has invested months of gestation, enormous energy, nursing, protection, and years of social care into one baby. A fish father may have several hundred embryos attached to a rock. The arithmetic is different. The more investment concentrated in a single offspring, the more expensive it becomes to abandon or consume that individual. This is why filial cannibalism often involves eggs, larvae, newborns, or large litters. But consuming offspring is never free. Every baby eaten loses its chance to survive and reproduce. A parent can misjudge which offspring are weak, consume too many eggs, destroy a brood that might have survived, or expose itself to pathogens. A parent that eats offspring too readily will eventually leave fewer descendants than one showing greater restraint. Evolution, therefore, does not favor parents that constantly eat their babies. It favors conditional behavior. Protect a healthy brood while the benefits exceed the costs. Reduce it when resources collapse or overcrowding threatens the survivors. Remove infected young before disease spreads. End the attempt when the remaining reward becomes too small. Cannibalism is an emergency tool, not the normal purpose of parenthood. Return to the fish beneath the rock one final time. He fans the eggs. A predator approaches. He charges forward and drives it away. Then he returns to the nest. One egg has died, so he eats it. Later, his energy begins to fall, and two more eggs disappear. The surviving embryos continue developing. Days pass. Tiny larvae finally emerge from the clutch and swim away. From the perspective of the 3 eggs he swallowed, he was a monster. From the perspective of the hundreds that survived because he remained beside the nest, he was an effective parent. Both views are true. That is what makes filial cannibalism so disturbing. The parent can protect its family and consume it at the same time. So, why do animals eat their babies? Because a dead or infected offspring can endanger the rest. Because an oversized family can exceed the food, oxygen, and energy available. Because a failing brood may cost more to protect than it can ever return. Because stress and uncertain parentage can change the value of continued care. And because, under the worst conditions, sacrificing part of a family may be the only way any of it survives. It is not revenge. It is not hatred. It is rarely a parent suddenly deciding that the babies look delicious, although several hundred eggs sitting directly beneath your face probably do not help. It is evolution doing arithmetic with living bodies. Humans look at the missing offspring and see a parent destroying its future. Evolution looks at the offspring that remain and asks only one question: how many will survive?